Welcome back to Calculus. We're working on question number 16. Our solution values are that x has to be between 2 minus delta and 2 plus delta, and also that x cannot equal 2. This problem's a little bit more tricky. So here's what we have. We have that 0 is less than, strictly less than, x minus 2, which is less than some delta value. So there's really two things going on here. So thing number one is that 0 is less than the absolute value of x minus 2. Thing number two is that the absolute value of x minus 2 is less than some number delta, which we haven't defined what delta is. It could be any number. Okay. We also know that delta is strictly greater than 0. So when I say that delta can be any number, it's got to be a positive number. Okay. Now let's play around with both of these and see what they say. Okay, so this guy over here, it says that the distance between x and 2 has to be positive. So the distance between x and 2 is positive, which means that the distance, not only can the distance be negative, but it can't be 0. So the distance can't be 0. Well, what would that mean? If the distance between x and 2 was 0, then that would imply, so if x and 2 had a distance of 0, oops, then that implies that x would have to be 2. They'd be the same number, right? If their distance is 0, that means they're on top of one another, or they're the same exact value. So if you think about this in terms of a number line, if here's the number 2, okay, I'll mark it as a red dot here, then x has to be not 2. So x can be anywhere it wants. It can be all the way over here. It can be all the way over here. So x could be over here. X could be over here. It's cool anywhere it wants to be. It just can't be right here. Okay, so that's what this first guy says right here. That's important because when you start working with epsilon delta proofs in calculus, or in, let's say, an advanced calculus course or real analysis, this is going to be part of the issue. We need to make sure that our x value is not equal to 2. Okay, so that's the first one. So we're good. The first guy says, I'm just going to write this over here. The first guy says x is not 2. It's all that this statement right here says. So let me erase that now and talk about the other part. Okay, so for the other guy over here, it says that the distance between x and 2, I'll write this down for you, the distance between x and the number 2 must be less than some number, some positive number delta, must be strictly less than some value delta. Okay, well, what does that look like? Well, here's the number 2. We know that x can't be equal to 2 because of this first part over here. So x must be somewhere, maybe out here, or maybe over here somewhere. What we do know is that its distance between x and 2 must be less than some delta. So delta, let's say delta is, I'm not going to use that mark for it. Let's say delta is here. So the delta being, I shouldn't say delta, that's not actually delta. Delta is the distance over. So the distance between x and 2, must be less than some delta. So if we subtract delta and we add delta, okay, the distance, let me erase this so we have a little bit more room. The distance out this way is delta, the distance this way is delta. So what is this guy on the number line? Well, this guy on the number line is 2 plus whatever delta is. If delta was 3, then it'd be 2 plus 3 or 5. Okay, so if I'll do that in a second. I'll do an example with a number here. And then, of course, this guy right here is 2 minus delta. So what does that tell me? That tells me that x, remember, x has got to fall somewhere in that range, and it can't be equal to 0. So, or the distance can't be equal to 0, so it can't be equal to 2. So 2 minus delta has got to be less than x, and x has also got to be less than 2 plus delta. And that's our answer. This right here is this right here plus this. So this and this guy right here, they have to hold. So clearly delta can't be 0 as well. Now if you picked a value for delta, let me just do this with a number here and show you how this works. So let's say you said something like this. You said 0 is less than or equal to x, let's do minus 2 again, is less than, let's say, 3. Well, what does this all mean? Well, first, again, over here, this guy right here says that the distance between x and 2 can't be 0. If you want to do this out, you could say, okay, x minus 2, okay, is greater than 0. That's the first guy. Or negative x minus 2 is greater than 0. I should rewrite that. If we do the math here, this guy right here gives me that x has to be more than 2. And this guy right here, if I multiply both sides by negative, remember negative 0 is just 0. So if I move this over, this says that x is less than 2. Right? So either x is greater than 2 or x is less than 2. So what does that look like? That looks like a number line. Here's 2, where x can be less than 2. X can be greater than 2. It just can't be equal to 2. So this says that x is not 2. Now the other side of the coin is that x minus 2 has to be less than 3. Well, again, if we take a look at this, this means that, we can do this out algebraically, I'll do it out in a graph in a second. This means that either x minus 2 is less than 3, or negative x minus 2 is less than 3. And if we do the math here, we end up with x less than 5, multiply both sides, add 2, okay, x negative 1. So x has got to be greater than negative 1. So here's negative 1. X has got to be less than 5. So it's got to be in between this area. But there's a little piece in there that it can't be, because it can't be equal to 2. And 2 falls in there, right? Here's 2. So let me just sketch that out a little bit better here for you. So here's negative 1. Here's 5, also 2. It can't be equal to 2. It's got to be greater than 1, but also less than, greater than negative 1, but less than 5. So she is in here, not including these endpoints, right, because of this. If you were to draw out the graph like I did earlier, here, remember I said this is our answer? Here, our delta value is 3. So this would be 2 minus 3 is less than x. I'll slide up just a little bit so you can see this a little bit better. Remember, this was our picture. And so delta was equal to 3. And so you'd have 2 minus 3 is less than x, which is less than 2 plus 3. So that means x is between negative 1 and 5. That is exactly what we just found here, that x was between negative 1 and 5. Now that's not including this piece right here. So if you're going to write this, you probably want to do it with interval notation so that you could say the following. We're going to go from -1, not including it, to 2, union 2 to 5. And then notice that we're not including 2 here. So this right here is your complete solution set, and every number in here satisfies this original equation. That's the idea.